Open feature matching for multiple images. How can I optimize the sift feature matching for many pictures using flann? I have a working example taken from the Python Dvoks. However, this is comparing one image with another and it's slow. I needed to search for features matching in a series of images, a few thousands, and I need it to be faster. My current idea. Run through all the images and save the features. How? Compare an image from a camera with this above base, and find the correct one. How? Give me the result, matching image or something. Update. After trying out many things, I might have come closer to the solution now. I hope it's possible to build the index and then search in it like this. However, I still haven't managed to build an accepted array to the flann_index parameter.
I never solved this in Python, however I switched environment to C++ where you get more open examples and don't have to use a wrapper with less documentation. An example on the issue I had with matching in multiple files can be found here, this URL.
Along with the reply of @StanleyChu 2005, I'd like to add some tips as to how to do the whole matching itself since I'm currently working on such a thing. I strongly recommend to create some custom class that wraps around the CV:\mat but also stores various other essential pieces of data. In my case, I have an image container store the original image that I will use for the final stitching, the processed one, grayscaled, undistorted, etc., its keypoints and the descriptors for those. By doing so, you can access all the matching relevant information in a pretty well organized well. You can either implement the keypoint extraction and descriptor generation in it or do that outside the class and just store the results in that container. Store all image containers in some kind of a structure. Vector is usually a good choice for easy access. I also created a class called Image Multimatch Container, which stores a pointer to a given query image. All images are query images, a vector with pointers to all train images, for a single query image of the image. All others are train images that will match to it, and also a vector of the match vectors for each of those matches. Here I stumbled across a storage issue, namely, first you have to skip matching of an image with itself because it is pointless, and second you have the problem of comparing two images 2 times, and thus generating a considerable overhead if you have a lot of images. The second problem is due to the fact that we iterate through all images, query images, and compare them to the rest in the set, train images. At some point we have image X, query, matched with image Y, train, but later we also have image Y, now query, matched with image X, now train. As you can see, this is also pointless since it's basically matching the same pair of images twice. This can be solved, currently working on this, by creating a class match container that stores a pointer to each of the two images in a match pair and also the match vector. You store this in a central location. In my case, this is my matcher class, and for each image as query image you check the list of matched images of the train image. If it's empty, then you create a new match container and add it to the rest of the match containers. If it's not, then you look in it and see if the current query image is not present there. Comparing pointers is a fast operation. If it is, then you just pass the pointer to that match container's vector item that stores the matches for those two images. If that is not the case, you do as if it's empty and create a new match container, etc. Matching containers should be stored in a data structure with a small access time, since you will be looking at them a lot and iterating from start to end costs too much time. I'm considering using a map, but maybe a tree of some sort can offer some advantages as well. The homography estimation is a very tricky part. Here I recommend you look at bundle block adjustment. I saw that the Stitcher class in OpenCV has a bundle-based class, but haven't tested it yet to see what's in it. A general recommendation is to look at the stitching process in OpenCV and read the source code. The stitching pipeline is a straightforward set of processes, and you just have to see how exactly you can implement the single steps.
Here are several pieces of my advice. You should reduce the amount of point data by using proper techniques. Calculate the reference image repeatedly is a waste. You should persist in all calculated reference. Do not put the calculate on a mobile device. You better upload the calculated reference of a captured image to a powerful server and do the searching there. This is a very interesting topic. My ears are opening too.
If you want to see more, please consider subscribing.